Hi there, in this lesson we're going to be looking at what we call permutations and combinations. And really these are just things that allow us to find the number of outcomes, how many ways something can happen given a certain situation. So we're first going to look at permutations. And a permutation is the number of outcomes when order matters, okay? When we're arranging things or when we're lining things up or when we're placing in some kind of competition. When order is important, when first place is not the same thing as third place, okay, that's when we want to use a permutation. And we denote permutations this way. It's n permutation r, okay, or n choose r, all right? And n here is the total number of options. So this is the total number of options. And r is how many are being chosen, so how many we're looking at, or how many we want. Okay, so again, n is the total, r is how many we want, and really we're just plugging this into this formula. It's going to be n factorial over n minus r factorial, and that'll give us the total number of options here, all right? For example, if I look at something like this guy, I've got the permutation of 5 choose 2 or 5 permutation 2. So the n value here is 5, so I do 5 factorial over n minus r factorial, so it's 5 minus 2 factorial. And now I just need to simplify this thing. That's a 5 factorial over 3 factorial, which remember I can reduce factorials by canceling out everything from 3 on down, which leaves me with a 5 times 4. Everything else canceled out, so that's just going to give me a 20. And that's it, okay? So when I have 5 things and I'm picking 2 of them to arrange in a specific order, there's 20 different ways that I can do it, all right? If I look at something like this guy, again, it's the permutation of 12 choose 3 or 12 permutation 3. So I would do 12 factorial over 12 minus 3 factorial. And then from here, I just simplify this. Again, that's going to be 12 factorial over 12 minus 3, which is a 9, so that's 9 factorial. And once again, I can simplify this. Everything from 9 on down cancels, so I'm just left with these 3 values. Again, everything from 9 on down canceled, so now I have the 12 times the 11 times the 10. And you can just plug that into your calculator. It looks like it gives you a 1,320. So again, that means that if I have 12 things and I'm going to pick 3 of them to line up, there are 1,320 different ways that I can line up those 3 things based on how many I have to choose from. All right. If I look at an example like this, there are 10 finalists in a math competition, and we want to know how many ways can gold, silver, and bronze medals be awarded. So again, I'm going to set up a permutation, and I know it's a permutation. I know that order matters because we're talking about gold, silver, and bronze. The gold medal is not the same thing as the bronze medal or the silver medal. Okay, first place is different from second place when we're talking about a competition. And if you don't believe me, ask any Olympian who has ever won a silver or bronze medal. They'll tell you they'd much rather have the gold. Okay, so these 10 finalists, so that means I have a total of 10. It's a permutation because order matters, and only the top 3 are being awarded medals. Okay, so it's the permutation of 10 choose 3. So it's 10 factorial over the 10 minus 3 factorial. And now I just simplify this. That's 10 factorial over 7 factorial. Everything from 7 on down cancels out, so it's 7 times 9 times 8. So I do the 10 times 9 times 8, which gives me a 720. So there are 720 different ways that those medals could be awarded to those 10 competitors, or really to those 3 competitors out of the 10. Okay? If I look at something like this, how many ways can a class of 12 students be arranged in 12 seats? So that would be 12 total students, or 12 total seats, and I'm placing 12 students in each of them. And again, the word arranged is what tells me that order matters here. I'm arranging the students in a specific order. That's going to be 12 factorial over 12 minus 12 factorial. And it would seem for a moment that this isn't working out properly because I do 12 minus 12, which is 0. So I have 0 factorial. But remember, 0 factorial is actually equal to a 1. All right, and it's important to remember that. So 0 factorial equals 1. So really all I have here is 12 factorial. 12 over 1. And so I plug the 12 factorial, 12 times 11 times 10, all the way down to 1 into my calculator, and it gives me this. This huge number. And now we ask this continuation question of, well, what if there are 15 seats? What if I'm doing 15 factorial, 15 choose 12, okay? In other words, now I have 15 factorial over 15 minus 12 factorial, okay? And when I do that, sorry, I have my factorial in the wrong spot here. That could have been disastrous. When I do that, that's a 15 factorial over, that's going to be a 3 factorial. So everything from 3 on down cancels out. So I still have the 15 times 14, and I just keep counting down the 13, 12, 11, 10, all the way down to 4. And when I do that, my calculator spits out something that looks like this. 7, 9, 4, 5, 7, 2, 8, and then it gives me this capital E and then an 11. Okay? By just adding those 3 extra seats, I have so many more possibilities. This is scientific notation. It's telling me that it's this thing, that's what that E means, times 10 to the 11th power. It's so big the calculator couldn't even fit the whole number in here. Okay? And that's just by adding those 3 seats. So you can see how having different values here can make a big difference. Okay? If I look at this this last one for permutations, it says that an old spinster who's been collecting cats, of course, has 12 cats, and she lines up 4 of them for a creepy cat parade. That sounds wonderful, and just like a good time all around. And so we want to know how many creepy cat parades are possible. So again, it's a permutation. There are 12 cats, and she's picking 4 of them. So it's 12 factorial over the 12 minus 4 factorial. And again, order matters here because we're lining them up. That's the key word here, the fact that we're putting them in a line. All right? Being first in line is not the same as being last in line. All right? So we've got 12 factorial over. When I subtract, that's an 8 factorial. And so now everything from 8 on down cancels. I just have 12 times 11 times 10 times 9. Okay? So I plug this into my calculator, the 12 times 11 times 10 times 9. And it looks like it gives me approximately or exactly 11,880. Okay, 11,880 different ways that we can line up these 4 cats out of the 12. Okay. The other thing we're going to look at today is combinations, and a combination is the number of outcomes when order doesn't matter. Okay, when order is not important. Okay, if I'm essentially choosing 2 vegetables and I'm mixing them together in a bowl, the order doesn't matter. It doesn't matter if I put the peas in first and then the carrots, or the carrots and then the peas. I still have this mix of those things. Okay, and really the only difference here in terms of the formula is I add an extra r factorial here. Okay, n is still the total number. R is still the number that we're choosing. So we have n factorial over n minus r factorial times r factorial in that denominator. Okay, and so really what it does is it helps to narrow down and reduce the number of possibilities here because I don't care about the order. All right, so for something like this, that's going to be a 7 factorial over the 7 minus 2 factorial, and then another 2 factorial for that extra r value. And when I do this, I'm just going to simplify this. That's going to be a 5 factorial, 2 factorial. Again, I have to pick and choose just like I did when I was reducing factorials. If I reduce the 7 factorial and the 5 factorial, leaves me with a 7 times 6, everything from 5 on down canceled. In the denominator, I still have my 2 factorial, which is 2 times 1. And so when I multiply this out, it gives me a 21. I multiply, I divide, it's 21. All right? For the next one, I do the same thing. This is an 8 factorial over. This is going to be an 8 minus 5 factorial, 5 factorial. And so when I do this, this is an 8 factorial over. That's a 3 factorial, 5 factorial. Again, cancel with the bigger one. The 8 factorial and the 5 factorial. Essentially reduce this to an 8 times 7 times 6. Everything from 5 on down canceled out. I still have the 3 times 2 times 1, the 3 factorial in the denominator. And when I multiply this out, that's going to give me a 56. I multiply, I divide, I end up with a 56. Okay? For example, if I look at something like this, it says, how many ways can a team of 5 be chosen from 11 athletes? Order doesn't matter here because it's not like I'm ranking them in any way. I'm forming a team, one cohesive unit. So I have 11 and I'm choosing 5. So this is a combination. 11 factorial over the 11 minus 5 factorial, 5 factorial. So that's going to be an 11 factorial over, that's going to be a 6 factorial, 5 factorial. Again, cancel with the larger of the two. When I do that, that's going to give me 11 times 10, 9, 8, 7. Over the 5 factorial, 5 times 4 times 3 times 2 times 1. Again, I can reduce this further if I want. Something like a 5 times 2 cancels with the 10. The 4 and the 8 can reduce to a 2 and a 1. The 3 and the 9 can reduce to a 3 and a 1. And really, it just gives me a little bit less to plug into my calculator. You don't have to do that. It's just an option to give you a little bit less to punch into the calculator. It looks like it gives us a 462. Okay. Now look at the next one. It says a group of 7 campers are attacked by aliens. It's a pretty common event. The aliens abduct 2 people and then leave, and we want to know how many ways can the 2 campers be chosen. And once again, the order doesn't matter here. It doesn't matter if they abduct, poor Jimmy and little Susie, or if they abduct little Susie and then poor Jimmy. They're still walking away with the same 2 campers. So order doesn't matter here. And typically, when order does matter, it'll be fairly obvious. So we've got 7, and we're choosing 2. So it's going to be 7 factorial over the 7 minus 2 factorial, 2 factorial. And I just start reducing these things. It's 5 factorial, 2 factorial. I can cancel the 7 and the 5 to create a 7 times 6 in the numerator, and then a 2 times 1 in the denominator. Okay? Everything from 5 on down canceled. And so when I do this, it leaves me with a 21. Okay? If I look at this last one, this one's a little bit more complicated. I've got 5 cards are drawn from a standard deck of cards. I want to know how many hands can consist of 3 clubs and 2 diamonds. All right, and this one's tricky because essentially 2 things are happening here. I've got clubs that are being chosen, and I also have diamonds that are being chosen. And so what I need to do is I actually need to do a combination for each of these. And it's a combination because order doesn't matter. It doesn't matter what order I get the cards in. I still have the same hand. I still have the same grouping of cards. So for the clubs, for those of you who don't know, there are 13 clubs in a standard deck of cards. And I obviously wanted 3 of them. For diamonds, there are 13 diamonds, and I'm choosing 2 of them. All right? And so now I have to do a combination for each of these things. So this one's going to be a 13 factorial over 13 minus 3 factorial, 3 factorial. This one is going to be a 13 factorial over 13 minus 2 factorial, 2 factorial. Here, this is going to give me a 13 factorial over. That's going to be a 10 factorial and a 3 factorial. And once again, I can reduce that. Everything from 10 on down cancels, which means my numerator is just going to have a 13 times 12 times 11. The denominator still has that 3 factorial in it. It's the same thing over here. I've got a 13 factorial over. That's going to be an 11 factorial, 2 factorial. Once again, when these cancel, in the numerator I'm left with 13 times 12. In the denominator I still have the 2 factorial. And so now I can pretty easily simplify this thing. So let's see, I've got the 13 times 12 times 11 over the 3 factorial, which is going to give me a 6. So when I do this, this guy gives me a 286. This guy over here, the 13 times 12 divided by the 2 factorial, gives me a 78. But now what do I do with those 2 numbers? I want one answer. Well, think about what this means. There are 286 ways that I can get the 3 clubs. There are 78 ways that I can get the 2 diamonds. This is my fundamental counting principle. If there's 286 ways that the first thing can happen, 78 ways that the second thing can happen, to find out how many ways they can happen together, I multiply these together. That's my fundamental counting principle, and that gives me a 22,308, and that's it.